Hello viewers, in today's lecture we are going to take up some important problems which will be solved by using the second fundamental theorem of integral calculus. So the theorem states that let f be a continuous function defined on the closed interval ab and f be an antiderivative of f, then the integral of the function f of x from a to b is given by the difference of this function at the points b and a, right? Suppose the definite integral of f of x is fx, which is also known as the antiderivative of f, then the definite integral of this function from a to b can be calculated by finding the value of this function capital F of x at b and a, right? So we write f of b minus f of a. So viewers, this is an important theorem in integral calculus which helps us to find the value of the definite integrals. For example, let us take a very simple example. Suppose we have to find the integral from 1 to 2 and say we have x dx. Now let us call this integral as I. Here this a is known as the lower limit and b is known as the upper limit, right? So what we will do, we'll first find the indefinite integral of x, and here we'll make use of the formula, that is x raised to n dx, which is x raised to n plus 1 n plus 1. So here we have x square over 2, and this x square over 2 is this function, that is capital F of x, right? Now we'll substitute this value here, that is x square by 2, and here a is 1 and b is 2, so we write 1 and 2. Now we'll first evaluate this function at this point, that is 2, so this is 2 square by 2, and then we will evaluate this function at x equal to 1, so this is 1 square over 2, and we subtract both these values. So here we get 4 by 2, here we have half, so this is 3 by 2. So therefore we can say that the integral of x from 1 to 2 is 3 by 2, right? For more clarity, let us take one more example. Suppose we have to find the integral of say cosine x from 0 to say pi by 2, right? Now viewers, let us call this integral as I. Now our first aim is to find the antiderivative of this function, that is we have to find the indefinite integral of cosine x, and the indefinite integral is sine x, right? So here we'll write sine x, and then we'll evaluate this sine x at these two limits, that is this is the lower limit 0 and pi by 2 is the upper limit. Clear? So this is sine pi by 2 minus sine of 0. Now sine of pi by 2 is 1 and sine of 0 is 0, so this is 1. So therefore the value of this integral is 1, right? So here's the second fundamental theorem of calculus says that the integral of fx from a to b, which is also known as the definite integral, is equal to f of b minus f of a, right? So let me take one more example. Now let us take one more example. Say we have to evaluate the integral from 2 to 3 1 over x dx, right? Let us call this integral as I. Now we know that first we have to find the indefinite integral of this function 1 over x, and we know that the integral of 1 over x is log of x, right? So we write here log of x, and we'll evaluate this antiderivative at 2 and 3. So we have here we have 2 and here we have 3. So this is log 3. First we will substitute the value of 3 here. So this is log 3, then we have log 2, and then we write it as log 3 by 2 by making use of the properties of logarithms, which says that log m minus log n is equal to log of m divided n, right? Okay. Now let me take one more example. Suppose we have to find the integral 4 to 5 e raised to x. Now let us call this integral as I. So what is our first aim? Our first aim is to find the indefinite integral of e raised to x, which is e raised to x. So here's this is e raised to x, and we have to find the values of e raised to x at 4 and 5, and then we will subtract them. So this is e raised to 5. First we'll substitute 5 here, and then we have e raised to 4, right? And if we take e raised to 4 common, then we have e minus 1. So this is the required value of this integral. Now let us take one more example. Suppose we have to find the integral 0 to 1 and dx over 1 plus x square. Now the indefinite integral of 1 over 1 plus x square is tan inverse x. So we can write here tan inverse x, and then we will evaluate this function at 0 and 1, right? So we have here tan inverse of, first we will substitute 1 because we have to find fb, then we have to find fa, and then we find the difference. So this is tan inverse 1 minus tan inverse 0. So tan inverse 1 is pi by 4 and tan inverse 0 is 0. So here we have pi by 4. So this is the value of this integral, right? Okay, now let me take one more example. Say we have to find, suppose we have to find the integral of say 0 to pi by 4, and we have sine 2x, right? Now here we have to find the indefinite integral of sine 2x. That is equal to the integral of sine x is minus cos x. So here's it is minus 1 over 2 cos of 2x, right? Now we write minus 1 by 2. This is cos 2x, and we have to find the value of this function at these 2 points, and then we will take the difference. Now here we have a constant term here, minus half, so it is better to take it out. So this is minus half, then we have cos 2x, this is 0 to pi by 4. Now this is minus half, then we have here we'll substitute x equal to pi by 4, so this is 2 times pi by 4. Then we have cosine of 0, right, because here we'll substitute x equal to 0. Now this is minus half, and this is cosine of pi by 2, and cos 0 is 1, right? So yes, here I am writing this is minus half, then we have cos of pi by 2 is 0 because this is cos 90 degrees, and it is minus 1. So this is minus 1 times minus 1, that is half, right? Now viewers, let us take this important problem. So here we have to evaluate this integral from 0 to 2 6x plus 3 divided by x square plus 4. So let us call this integral as I. Now viewers, here let me take the indefinite integral of this given problem. So here let us consider 6x plus 3 over x square plus 4, right? Now what we will do, we'll split it, this will split this integral into two integrals. So first is 6x over x square plus 4 dx, then we'll have 3 divided by x square plus 4 dx, right? Now here this integral can be written as if I write it like this, 3 times this is 2x over x square plus 4, right? Because 3 2s are 6x, so I have written 6x like 3 times integral of 2x divided by x square plus 4. And here let us take 3 common, and we have dx over x square plus 2 square, right? Now in the first integral we see that the derivative of the denominator is present in the numerator. So this is 3 times of log of x square plus 4, right? Okay, and then we have 3 times the integral of 1 over x square plus 2 square is 1 over 2, and then we have tan inverse x over a, that is x over 2, right? So here we have applied actually two results. The first one is if we have say f prime of x divided by fx, the derivative of f is present in the numerator, then this integral is log of fx, and when we have an integral like this, that is dx over x square plus a square, then this is 1 over a tan inverse x over a. So here for a we have a is equal to 2, right? Now the indefinite integral of this function is given by this expression. So let us come to the definite integral. So here now we can write 3 log x square plus 4 plus 3 by 2 tan inverse x over 2, and then here we'll have 0 to 2. Now we'll first calculate the value of this function at x is equal to 2. So this is 3 log, here we have 2 square plus 4 Then we have 3 by 2 tan inverse of 2 divided by 2, and then we'll have minus, we'll substitute x equal to 0 here. So we have 3 log, this is 3 log 0 square plus 4 plus 3 by 2 tan inverse of 0 by 2, right? So this is FB and this is FA, right? Okay. Now let us simplify this expression. So we have 3, this is 3 log, this is 4 plus 4 8, and this is 3 by 2, this is 2 and 2 get cancelled, so we have tan inverse of 1, and tan inverse of 1 is equal to pi by 4, right? So here we'll write pi by 4. Then minus, here we have 3 log 4, and then here we'll have tan inverse of 0, and we know that tan inverse of 0 is 0. So here we'll have 0. So in all we have 3 log 4, right? This term becomes 0. Now we have to simplify this term and this term. So here's, this can be written as 3 log 8 can be written as 3 log 2 cube, and this is 3 pi by 8, and here we have 3 log 2 square, right? Okay. Now by making use of the properties of log, log m raised to n can be written as n log m, right? So this is 3 log 2, and here we have already we have 3, so this is 3 3s are 9, so this is 9 log 2 plus 3 pi by 8, and then we have here this 2 comes to the front of this log, so we have 6 log 2, right? This is 6 log 2. So 9 log 2 minus 6 log 2 is 3 log 2. So we have this is 3 log 2 and plus 3 pi by 8, right? So the value of this integral is given by 3 log 2 plus 3 pi by 8, 3 pi by 8, right? Now viewers, let us take this problem. Here we have to find the definite integral of 1 over x square minus 1, and the limits are 2 to 3. So let us call this integral as I. Now viewers, here we are going to make use of the formula, that is dx over x square minus a square. Now the integral of 1 over x square minus a square is 1 over 2a log, and we have x minus a over x plus a, right? Now here we have x square minus 1, so this can be written as x square minus 1 square. So here a is 1, right? So the integral of 1 over x square minus 1 square is 1 upon 2 times of 1, substituting the value of a as 1. So we have log of x minus 1 divided by x plus 1, right? So this is half log x minus 1 over x plus 1, right? Okay, now the indefinite integral is this, so we have to just now evaluate this function at these points. So we have half log x minus 1 over x plus 1, and we have to find the difference in the values of that is FB minus FA. So here in this case this is F3, minus f2, right? So this is half, and we have log, this is 3 minus 1, this is 3 minus 1 over 3 plus 1, and then we have log of 2 minus 1 divided by 2 plus 1, right? So this is half, we have log, this is 3 minus 1, 2 by 4, which is equal to half, and then we have minus of log, and here we have 2 minus 1, 1, and this is 2 plus 1, 3. So this is log 1 by 2 minus log 1 by 3. Now this can be written as minus of log 2, and this is plus log 3. Here we have used the formula that log of 1 over m is equal to minus of log m, right? Log 1 over m is equal to minus of log m. Clear? Now this can be written as half log 3 by 2. Why? Because again we have used the property of log, that is log m minus log n is equal to log m divided by n, right? So this is the value of this integral. Now viewers, let us take this problem. Here we have to integrate x divided by x square plus 1 from the limits 2 to 3. So let us call this integral I, right? Okay, now here we have to find the indefinite integral of x divided by x square plus 1 dx. So here we see that if I multiply the numerator by 2 and here I put 1 by 2, then we see that this 2 and 2 gets cancelled. But here we see that the derivative of the denominator occurs in numerator. So the derivative of x square plus 1 is 2x. So this is simply a log of x square plus 1, right? Because we know that if we have f prime of x divided by fx, then the integral is log of f of x, right? Okay, so here we have half, this is log of x square plus 1, and we have to find the value of this function at 3 and 2, and then we'll take the difference, right? So here we have half common, so it means this is a constant, so we take it out, and we have x square plus 1, and this is 2 to 3, right? So we have half, this is log 3 square plus 1, and then we have minus log 2 square plus 1, right? So here's this is half, and this is log 10, 3 square 9 plus 1 10, 2 square 5 plus 1 5. So we have 2 square 4 plus 1 5, and now we write it as log 10 by 5. So we have half log 2. Here we have used log m minus log n is equal to log m divided by n. Now half log 2 can also be written as log of square root of 2. Now viewers, let us take this definite integral. Here we have to integrate cos square x from 0 to pi by 2. So let us call this integral I, and now we have to find the indefinite integral of cos square x. Now we know that cos 2x is equal to 2 cos square x minus 1. So this is the trigonometric identity for double angle. For cosine of 2x is equal to 2 cos square x minus 1. So we have cos square x can be written as 1 plus cos 2x divided by 2. So we substitute this value here. So we have 1 plus cos 2x divided by 2 dx. Now here's this can be written as half. We have 1 dx. Separating this integral from this point, that is plus sign. So we have integral cos of 2x dx, right? So this is half. The integral of 1 is x, plus the integral of cos theta is sine theta, and we have half sine 2x, right? So this can be written as x over 2 plus 1 by 4 sine 2x. So here's now this definite integral can be written as x by 2 plus 1 by 4 sine 2x, and we have 0 to pi by 2. Now here we have pi by 2, so we have pi by 2 divided by 2 plus 1 by 4 sine 2 times pi by 2, and minus, if we substitute 0 here, so we get 0, and when we substitute 0 here, this is sine 0, so this is again 0. So this is pi by 4, this is pi by 4, and plus 1 by 4, 2 and 2 get cancelled, so this is sine pi, and this becomes 0. So we have pi by 4, sine pi is 0. We know that sine pi is 0, therefore this term disappears from here, so we are left with only pi by 4. So the value of this integral is pi by 4. Now viewers, let us take this problem. Here we have to integrate sine square x by 2 minus cos square x by 2 from 0 to pi. So let us call this integral I. Now we know that from trigonometry, we know that cos square theta minus sine square theta is equal to cos of 2 theta, right? Now if I replace theta by x by 2, so we have cos square x by 2 minus sine square x by 2 is equal to cos of 2 times x by 2. Now this can be written as 2 and 2 get cancelled, so we are left with cos x. So this is the half angle formula for cosine of x, right? So here we have 0 to pi. Now sine square x by 2 minus cos square x by 2 is simply minus of cosine of x, right? So this can be written as minus, this is 0 to pi cos x dx. Now the integral of indefinite integral of cos x is here sine x. So this is from 0 to pi. Now this can be written as minus of sine pi minus sine 0, and we have sine pi is 0, sine 0 is 0, so we have 0, right? So the value of this integral is 0. Now viewers, let us calculate this definite integral. So here we have to find the integral from 0 to 1 of 1 over square root of 1 minus x square. So let us call this integral I. Now we know that this is a direct question. So we know that the integral of 1 minus x square is equal to sine inverse of x. So this is a direct result which we are making use of. So this is here we have sine inverse of x, and here we have 0 to 1, right? So now we write sine inverse of 1 minus sine inverse of 0. Now we know that sine inverse of 1 is pi by 2. So we have pi by 2 here, and sine inverse of 0 is 0. So here's this is pi by 2. So this is the value of this integral, that is pi by 2. Now viewers, let us take this problem. Here we have to integrate log x from the limits 2 to 3. So let us call this integral I. Now we have to find the indefinite integral of log x. Now we know that from integration by parts, we know that this integral can be written as 1 multiplied by log x, and here we'll take the first function as log x. So we have log x, then we have integral of 1, then we have integral, and then we have d by dx of log x, and then we have 1 dx, right? So here we have made use of the concept of integration by parts. So this is log x, and here we have x. The integral of 1 is x, and here we have 1 by x, and the derivative of log x is 1 over x, and the integral of 1 is x, and here we have dx. So this is x log x minus x and x get cancelled. So we have 1 dx, and this is log x minus x, right? So here's here we'll write x log x minus x, and this is 2 to 3, right? So we can write 3 log 3 minus 3, and then we have 2 log 2 minus 2, right? So this can be written as 3 log 3 minus 3. This is minus 2 log 2, and this is plus 2. So we have 3 log 3 minus 2 log 2 minus 1, right? So this is the required value of this integral.